Asir.
And I'm SHRIYA. We have done a capstone project titled IoT Based Forest Fire Detection and Cloud Based Alerting Network.
In this capstone project, we have used two sensors. One is DHT11 to measure temperature and humidity, and the other one is MQ6 sensor, which is a gas sensor. By comparing these three values, that is temperature, humidity and gas, we are going to detect the forest fire.
The analog pin of temperature sensor is connected to the 6th pin of CC3200 launchpad, and analog out pin of gas sensor is connected to the 2nd pin of CC3200 launchpad. 5-volt power supply and ground from the CC3200 board are connected to the breadboard first, and from there it is given individually to the sensors. This is gas sensor, that is MQ6 sensor, and this is temperature sensor, that is DHT11 sensor, and this is our whole setup. This system continuously monitors temperature, humidity and gas concentration and uploads the data to ThingSpeak Cloud for real-time observation.
The first two lines of the code include the required libraries. DHT.h is a library used to read data from the DHT11 sensor.
Then we define the sensor pins. DHT11 is connected to 6th pin of CC3200 launchpad, and MQ6 gas sensor is connected to the 2nd pin of CC3200 launchpad.
We also store our Wi-Fi name and password, and then the ThingSpeak server and our unique API key. This API key is like a password that allows us to upload data to our ThingSpeak channel. Finally, we create an object for the DHT sensor.
The setup function runs only once when the CC3200 is powered on. Serial.begin starts the serial monitor to display messages. DHT.begin initializes the DHT sensor. Wi-Fi.begin connects our CC3200 launchpad to the Wi-Fi network. When we then use a while loop to wait until the Wi-Fi connection is established. Once it connects, we print the IP address of CC3200. This helps confirm that our node is successfully connected to the internet.
Now let's move to the main loop function, which runs continuously. Inside the loop, 3 readings are taken: temperature, humidity, gas level. Read temperature and read humidity. Get data from the DHT11. Analog read reads the gas level as an analog voltage.
Then we check if the sensor values are valid. If readings are valid, we print them on the serial monitor. This helps us see live sensor readings while the code runs. Then we check if Wi-Fi.
Now let's see what happens inside the send to ThingSpeak function. A Wi-Fi client object is created to handle the HTTP connection. It connects to api.thingspeak.com on port 80. Then we prepare the post data string that includes our API key and 3 fields.
Next, the program sends this data to the server using an HTTP post request. After successfully sending, we print the same data on the serial monitor for confirmation. Then the client connection is stopped. If the connection fails, a message "Connection to ThinkSpeak failed" will appear on the serial monitor.
To summarize the operation of the whole code, the CC3200 connects to Wi-Fi. The DHT11 reads every 15 seconds. The CC3200 uploads the data to ThinkSpeak Cloud. On ThinkSpeak, we can review the data as live graph for analysis. This kind of system can help detect early sign of a forest fire, such as a sudden rise in temperature, drop in humidity, increase in gas or smoke level.
In terms of hardware, the connections are very simple. DHT11 sensor VCC is connected to 5 volt, ground is connected to ground, and analog data pin is connected to the GPIO6. And MQ6 gas sensor VCC is connected to 5 volt and ground is connected to the ground. Analog out is connected to the GPIO2. CC3200 connects to Wi-Fi and handles all data transfer. There are some small limitations and improvements we can make. Increase the delay to 15 seconds to respect ThinkSpeak limits. Calibrate the MQ6 sensor for accurate gas detection. Add a buzzer or LED alert when gas or temperature crosses a threshold. Add more sensors for better accuracy. Improve the code by adding a Wi-Fi reconnection function if the signal drops.
Advantages of the system: yearly fire detection. The system continuously monitors temperature, humidity, and gas level. Sudden changes can give an early warning of fire before it spreads. Cloud-based data monitoring. All sensor data is uploaded to ThinkSpeak Cloud, allowing real-time remote monitoring from anywhere using the internet. Authorities can visualize live graphs and trend without being physically present in the forest. Wireless operation uses Wi-Fi connectivity through the CC3200, so there is no need for manual data collection. The system can operate in isolated forest regions with wireless coverage. Low cost and low power. Components like DHT11 and MQ are inexpensive and easy to use. The CC3200 board is energy efficient, making it suitable for battery or solar powered setups. Simple design and easy implementation. The circuit connections are straightforward. The code uses simple logic that can be easily modified for additional sensors like flame or vibration sensor.
Real-time alerts and analysis. ThinkSpeak can be integrated with services like IFTTT or email or SMS alerts to notify forest officials instantly when critical values are detected. Scalable and expandable. The same setup can be expanded to multiple forest zones by deploying. In conclusion, this code successfully connects CC3200 to Wi-Fi, reads environmental data from sensors, and uploads it to the ThinkSpeak cloud. It demonstrates how IoT can be used for environmental monitoring and early fire detection in forest areas. Thank you.